Hey YouTube. Over the last couple of weeks, we've been talking about the radio transmitter and the GPS tracking system for the weather balloon project. Now, I believe this is going to work very well for when it's in flight. However, when it lands, I'm anticipating losing radio contact when it gets down to about 2,000 feet. Now, a lot of people talk about having a backup tracking system, but I think a lot of those actually use a cellular signal, which the FCC says cannot be used in flight. So this is my solution. This is a Cricket Bolts USB cellular modem. It has a micro SD card slot right here, and don't know why. Flip this out, we've got our USB, and it can rotate in different directions, so that's convenient. We have a external antenna connector right there, and over here we have our SIM card slot. I'm going to be using a SIM card from Ting Mobile. You can get these SD cards for about $10 directly from Ting. They are a pay-as-you-go, pay-for-what-you-use cell phone provider or cell service provider. So I'm only going to be using this for text messages, so that's all I've got to pay for. It's like $6 for the line, and then a couple dollars depending on how much text messages are actually used. The SIM card is a 3-in-1. We've got the full size, and then there's a micro and a nano SIM. You just pop it out for what you need. With this modem, it takes the full size SIM and it just slips right in there like that. Now if we flip it over, we can see the model information, and this is actually a Huawei E397 broadband modem. The actual model number here is E397U-53. And I will just plug this into the Raspberry like that. We've got a short USB cable here, so that makes positioning it easier inside the payload package. And initially we're going to get this green flashing light. That means it is attempting to connect to the LTE network. Now it's going to be flashing blue because we actually have a connection. So let's head over to the computer now, and I'll show you how this thing works and how I plan to use it in the balloon. Alright, so I've got things set up a little bit differently today. On the left we have VNC, which I'll be using for our Python coding later. And on the right I have a PuTTY terminal open, which makes things a lot easier when using a terminal window rather than doing it through VNC. So the first thing we want to do is install a USB mode switch. Now most versions of Raspbian already have this installed. I already have it installed, so we can see that nothing was installed. But this is necessary because the Raspberry Pi actually recognizes the device as a USB drive because it has its own software on there to install onto any other computer so that you can actually use it as a broadband modem. Now we can confirm that USB mode switch did its thing by typing ls USB, and that's going to show us what's connected. And we can see right here that the first thing on the list is our network card slash modem right there. So we know that USB mode switch is doing its thing. It makes the Raspberry actually identify it as the modem that it is. The next thing we need to install is Screen. Screen is a serial monitor that'll work right through the terminal window. Another reason I really like using PuTTY for this. Now to verify that everything is installed correctly, we're going to do ls/dev/tty star. And there we can see all of the serial ports. And the one we're interested in here is the TTY USB 0. That is our modem. Now to access the modem, we're going to type screen dev TTY USB 0. And first we get a blank screen here because the modem's not doing anything. But to interact with it, we're going to use something called AT commands. These are a set of it's a command language that's used for communicating with modems. I believe it's been in existence since the early 80s. And I don't know if it's really still used a whole lot today, but apparently a lot of devices still are capable of understanding AT commands. So the first thing I like to do is just type AT, make sure we have a good connection with the modem and it's doing what it's supposed to do. So now we can actually do something with this. The first thing we need to do is set its function. So you type AT plus CMGF equals 1. Okay, so now it's in the right mode. Then we need to set our set the storage mode to the SIM card rather than its own internal storage because we need to be able to delete that message after it's sent. So that is done by typing AT plus CMPS equals SM, comma, SM, comma, SM. It's got 3 different storage facilities in there. No, it doesn't like that. There it goes. That's what we want to see. And this just shows that there's 0 messages stored in each of those 3 areas. Now we're actually ready to send a message. So with the LTE modem, sending messages is a lot more complicated than it would be on a 3G modem. So what we need to do is compile a message, save it to storage, send the message, and then delete the message when we're done with it. On older modems, there was actually a single command to do everything with one step and not even save it. That would have been really convenient, but that method does not work with LTE modems. So first we're going to compile our message. So we're going to type AT plus CMGW equals, now we have to put a phone number in here. And now we're ready to send our message. Now, I'm not typing a message yet, but we have a list of information coming through, and that's actually the signal information. It doesn't affect the message that gets typed in here, but the modem just feels like telling us what the actual signal strength is at this point. So I'm just going to type hello world. And then we're going to hit Control Z. And it doesn't like that because I accidentally put an @ symbol. So now we actually have to do it again. CMGW equals phone number. Hello world, exclamation point. Control Z, and it says OK. Anytime it says OK, that's a good thing. And then right here, this CMGW0 indicates the storage position that the message is saved in. So when we go to send it, we're going to type AT plus CMSS, and then we'll identify which storage position we want to send from. And it says OK. Now, this line right here just indicates the total number of messages that have actually been sent. And I just got the text message. Next, we want to delete that message. So we're going to type AT plus CMGD equals 0. OK. And it deleted that message. Now, one last thing before we get into the Python script. I mentioned earlier that I don't want to use cellular devices in flight because the FCC says I can't do it. Good thing is with this modem, it supports airplane mode, or low power mode as they call it, that can be triggered on and off with AT commands. So it's actually AT plus CFun, which stands for functionality. And if I say CFun equals 4, that actually sends the modem into a low power mode that does not transmit nor receive any cellular signals, which makes it completely legal to be in the air. Now, to take it out of airplane mode, we just do AT plus CFun again. Oops, AT plus CFun equals 1, 1. Don't know why it needs 2 parameters there, but that's what it takes. That actually triggers the modem to restart, and then it brings it back into full power mode. The whole process takes about 30 seconds for it to get back into full power mode here. I'm still getting a green flashing light over here, but there it is. Now it's actually connected. It's done restarting. Sometimes the Pi gives me this error over here when the modem gets connected. I don't really know what triggers that, but it doesn't seem to affect anything, so I'm not worried about it. But we've got a blue flashing light over here, so I can get back into the terminal, and the modem's alive and well. We've got a blue flashing light. It's out of airplane mode, so everything should work great. Now, last thing we want to look at here is our Python script. It's actually a lot easier than I thought it would be to do this. We just have to import the serial library. I'm also going to import time from sleep. We're going to define our serial port. So I've named it GSM, and right there is the connection that it has that we saw earlier, /dev/tty USB 0. Now, actually, let's close out of this real quick. Hit Command A and K. And yes, we don't want that serial connection interrupting this serial connection, which is why I have this sleep in here, because we're going to open it after it opens the serial port in Python so we can watch everything happen to verify that it's doing everything correctly. So the first thing we're going to do is we're going to send it the command AT. Now, the serial port only understands bytes, so we can't just send it a simple string. This B right here in front of the string automatically converts the string into bytes. And then we have a \R, which is our enter key. Now I do like to rest half a second between commands to make sure the modem receives and processes the command before we move on to the next step. Otherwise it can get stuck. Next we're going to do our CMGF, set the function to mode 1. We're going to set our storage, and then we're going to set our character set. I was running into problems with that before. I don't think it's necessary, but I'd rather have it there than not have it. We've got the phone number here with the CMGW command, and then we're going to actually type the message in here. And remember when we did that earlier, we had to press Control Z. We can press Control Z with Python with this right here, X1A, which I believe is a binary command for the Control Z function. Then we're actually going to, let's change this to 0.5. And then right here we're going to send it. Now I need to change this to 5 seconds because sometimes it'll get stuck in the send mode and then actually send the message, but the message won't get deleted, which can cause issues down the line. So then right here we're going to delete the message in position 0, and then we're going to close our serial port at the end here. So let's go ahead and run this. Then I can come over here and open the serial port. And in a moment, we'll see it do everything we just did, just a lot faster. I gave myself 15 seconds there just to make sure I could get it open, and there it goes. that took all of, like, what, just a couple seconds. You should be getting the message here any second now. There it is. Now, when it actually comes time to use this with the balloon project, I will be taking the GPS data from the GPS module that I already have on board. No need to get a second GPS if I've already got one. And then I'll parse the data into strings and then to bytes and text myself the GPS coordinates after the balloon has landed. But that's going to be another story for another time. I will cover that in detail next week. So until then, make sure you subscribe. Let me know what you thought below, and I'll talk to you all next week. Thanks.